Hi, and welcome to Cloud Cover. Today I'm joined by Chris Risner.
Hello, Nick.
And Sinclair Schuller.
Hey, Nick. Thanks for having me.
No problem. So you're from Apprenda.
Yeah.
And could you give us a little bit of a description of, I guess, your job role at Apprenda and what your product actually is and does?
Sure. So I started the company as a co-founder in 2007. Currently, I'm the CEO of the company, but I started the company based off of a set of personal experiences that my co-founders and I had. We worked inside really large enterprises and had to deal with the friction associated with getting new apps up and running. So I was on a development team there as a software developer, and this was at the time at Morgan Stanley, and we got to see what it was like to be in those environments. And the typical type of IT environment is one where the developer goes in 9 to 5 working on building an application, and that process could take 3 or 4 months. Your average app would be like a 3 to 4 month build project. Interestingly, the work didn't stop there. You would build an application, and then it would take you 3 to 4 months to get it up and running. You'd have to call 10 different teams, security, DBAs, you name it. And ultimately, 90 days later, they'd get the infrastructure prepped so that you could run the application. So the time to market for getting an app out there was like 6 months.
Yeah.
That was pretty frustrating. And then the second thing that was frustrating is that if you look at an organization like that, the amount of time that gets invested in reinventing the wheel over and over again tends to be very high. You tend to do things like scaling and availability and architecture patterns as exceptions to the rule with every single app. So there was never a standard in terms of how people would build applications. And this is true for any large organization. So we started the company with the idea of what if we could build a layer, a piece of software that could sit across the entire enterprise data center or multiple data centers and also incorporate public cloud resources from Azure and turn it into a unified pool of resources that would do 2 things. Make it where the Sinclairs of the world that are sitting inside those enterprises writing those apps could get an app out the door in 90 seconds, not 90 days. So your app is done.
That's pretty good, yeah.
Yeah, right, like at a button click, could we get it deployed? And then second, could we make it where that layer would also act a lot like an operating system, providing those applications with a lot of the fundamental building blocks for building new apps, or taking the existing app portfolio and modernizing it?
Right, so where you say you'd take it from 90 days to 90 seconds, that's typical with cloud, but this solution helps, compliance with those RT policies that typically would make it take 90 days to get something out there, or is it? It
does. With the processes and policies, if you look at what actually took 90 days in most of these cases, is that a lot of the work was manual. So you'd provision servers or virtual machines manually. You'd have to provision databases manually. Somebody would tune the load balancers to accept requests, for example, at the URL level. All those were manual processes. And then second, they had to fit a set of constraints that mattered to that particular enterprise. So if you could create something that would enforce policy and ensure that things were deployed exactly as expected, and then second, to commoditize the amount of time required in those manual processes to be automated, then all of a sudden you've hit nirvana, right? It's the idea that 90 seconds can actually happen. So in a lot of ways, what we do is we help these organizations reshape their data center footprint to look a lot like the public cloud.
All right, cool. So are we going to see it today?
Yeah, we definitely love to walk through it and give you guys some hands-on perspective.
Sounds good.
So the one thing that I want to do is quickly describe the tech at a pretty low level. So the way that Apprenda works is that we're a peer-to-peer fabric. We'll take a bunch of Windows instances, that could be VMs running on Hyper-V. We could take Linux instances, SQL Server instances, and actually turn them into this unified on-premises fabric. So our customers take our technology and might take these resources from a bunch of different data centers and pool them together into this single fabric idea. IT then exposes that to all the developers inside the company to use as their internal cloud. But here's the trick, right? That's a practical, low-level solution for a problem that enterprise has today. What about public cloud? One of the other things that Apprenda does is it can federate resources from Azure and turn it into one platform. What we want to do is get rid of the distinction between the private data center and the enterprise IT footprint and Azure. That should feel like one seamless system. So Apprenda aggregates all those resources, and you can kind of get a sense here. If you look at this portal, you'll see, for example, that we take all these servers in your Apprenda footprint and aggregate the memory. This is a very small footprint, 45 gigabytes of memory across all operating system instances. Some of our customers are in the multi-terabyte range. Now, where do the servers come from that make this up? This is what we're going to zoom in on. If you go to this infrastructure tab and I click on clouds, I'll notice 2 things. I'll notice my private data center contributing 4 servers total. And then I'll notice that I've federated an Azure instance, in fact, 4 IaaS instances as part of my one seamless fabric. So Apprenda can take multiple data centers, take your Azure resources, and turn it into one view, right?
Yep.
One fabric.
That's really cool.
Yeah, it's interesting because it removes the idea that public cloud or Azure is a place, right? It's part of the resources that you're going to use on a regular basis, and it disarms the equation. As a developer, you're no longer thinking, geez, am I going to deploy to Azure? Am I going to deploy on premises? In fact, you write a single application the way you normally would.
Right.
And our technology exposes an internal application platform that will dictate what side of the fence the application is going to live on. Okay?
Yep, yep.
So if I zoom in a little more, I can actually look at those servers that make up the Apprenda instance. So clicking on that server tab, I'll see a bunch of servers pop up. We have some Linux instances running on Azure. We have some Windows instances. Now, a salient point here is that we're an application platform for .NET and Java apps.
Right.
So if you're a .NET or Java developer inside the enterprise and you log in, you're going to log into a portal that I'll show you in a little bit.
Yep.
And in that portal, you manage your applications. This is the IT view. This is where the IT department is configuring their data center footprint, the Azure footprint as that seamless whole.
Yep.
Okay. Each one of these servers has hosting responsibilities. So when a developer deploys an app on Apprenda, they never remote desktop into a machine. They never say, here's my app, and this part of the app is running here. Instead, they say, here's my app. It's a composite application with a SQL Server database, maybe some Java and .NET, maybe some JavaScript and HTML5. And I need it to run this way. I need this many instances. And oh, by the way, this app has personally identifiable information. In that case, I could, on the IT side, create a policy that says any app that has personally identifiable information has to live in one of our data centers.
Okay.
So, for example, banking or healthcare, that would be the case. If the app doesn't have that information, I actually want it to go to Azure, right? So now we've taken what was a technical decision, should my app be on Azure or should it be on premises, and turned it into a business requirement, right?
That's great. That's really cool.
Yeah, it's practical, right? I think ultimately what we try to do is have practical cloud. We want somebody to look at this and say that I don't really need to worry about how things happen. Imagine worrying about, if you're allocating memory as a developer, what stick of RAM on your PC that memory needs to live on. So that'd be awkward.
So in the case where you had, say, PII, if I'm the app developer, we may see this later, but if I'm the app developer, I'm saying, okay, I've got PII ticket, deploy it through here. It's sort of similar to a PaaS style of thing where Apprenda is going to pick that up and say, okay, we've got PII data here. It's going to be deployed to one of our on-prem servers.
Correct. In fact, I'll show you that right now. So the way it works is the IT department is responsible for creating the policies that shape these sorts of discussions, right? So in Apprenda, we have a thing called application deployment properties, policies and custom properties.
Right.
A custom property is essentially a metadata tag that I can assign to a server infrastructure or an application.
Okay.
So here we have one called PII.
Yep.
We say that they apply to servers and applications.
Right.
Okay. And associated with that is I have a application deployment policy, which will tell me that there's certain evaluation logic on how to treat that particular piece of metadata. So here I say that any application must match a server that has personally identifiable information tags.
Yep.
Okay. If we go back to our infrastructure tab and I look at that server, I can drill into any one of these servers and see what that server is designated as. So I'll go to a Windows machine in my data center, for example, node 2. And the IT staff tagged this particular server with saying, yes, this is an enforced PII server.
Right.
So any application that the developer specifies has PII will land here.
All right.
If I go look at an Azure instance, in that case, I'll see something actually a little different. What I'll see is that it'll say no. So let's zoom into that. And ultimately what happens is if you take these application policies, these custom properties, and the designation at the server level, we actually will then shape the deployment of the app from the developer's perspective based on it, but they don't ever know that that happens.
Right.
And then from the IT admin side, once they've set up these properties and configurations, they don't then have to worry about deploying it themselves. They can just say, these are the rules, go ahead and take care of it.
They don't have to worry about deploying it, and they also don't have to worry about enforcement, right? The old approach, and being that I come from that world, it would be that somebody would come in and say, here's a piece of paper with the things that we expect you to do policy-wise, right? Don't do this, do that. That doesn't work. No developer really follows them.
Sure.
So now we're going to switch to the developer portal and kind of have a different persona in the system. As a developer, I get my own portal where I get to deploy my applications. Part of being a developer in Apprenda is that I log in and I manage my apps either through this portal or through an API or through a command line.
Okay.
Right. We have an application already deployed here called Timecard.
Okay.
And I could have 1, 10, 15 applications. Anybody who's registered in this account as part of my team can get access to it.
Okay.
And this application, when it was deployed, was actually deployed under the auspices of this deployment policy. The app was evaluated for whether it has personally identifiable information or not. The way that happens is that the IT department who established those controls can force a developer to answer questions. So now there's an audited trail saying this developer said that this app is safe, it doesn't have PII, and then the deployment decision actually would happen because of that.
Okay.
So the developer view of Apprenda is one where I get to manage my application, I can see how much CPU and memory has been allocated regardless of what cloud it's on. I can stop the application, launch it, export it if I want to move it to a different cloud, or monitor specific pieces or even scale the app. All of these operating profiles, these capabilities and workflows around operating my application are abstracted away into our platform, so you no longer worry about what scaling means on Azure versus on-prem. It's all one seamless environment.
Okay.
I can set things up like automated scaling, so I can tell the platform, hey, you know what, I would like to have automatic scheduling of this particular web service, and automatic might mean that I want no more than 10 instances and no fewer than 2. And when CPU for any instance or all instances of this particular web service hits a certain threshold, scale out an instance for me automatically.
Okay.
I could do scheduled and do it by day of the week.
Yep.
So really try to fold all the controls around app management in such a way that we empower the developer to achieve these outcomes. And that could be, again, whether it's running on the Apprenda portion on-prem or on the Azure portion of that fabric.
Right. Very cool. So you're probably using maybe the Windows Azure management libraries that were just released to sort of manage your basically your auto scale and rule configuration.
Yeah, in this particular case, we actually connect directly to the IaaS instances. So if I have some CentOS and Windows Server instances running on my Azure account, I can federate those with Apprenda, and then we provide a scaling overlay to that.
Okay.
So we try to really make the concept a seamless concept. The last thing we want is that the developer and the IT staff has to do different things in different environments. We believe that actually gets in the way of cloud adoption. So we try to ensure that through this approach, we can get more applications off of the data center and into the public cloud, but doing it on the customer's terms over time, right?
And you're really basically hitting the two places where people want to scale. One where it's sort of automated, perhaps there's peaks or bursts in terms of usage of those particular resources, and scheduled where you've forecasted that perhaps it's end of week processing of reporting for accounting or something like that.
Correct. We see this it changes industry by industry, but you look at somebody like retailing industry, right? Retailing will typically post transactions from stores on a Friday or a Saturday. That batch job posting of transactions might hit web services running on Azure, and you may not need very many instances on any other day of the week but Friday. So that scheduled approach fits a lot of business workflows that I think are typical in certain industries. On the bursting side, when there is very little predictability around your workload, that's where the automatic comes in, and it's around measuring specific properties of the application. And of course, there's always manual mode, which is enabling a developer to establish mins and maxes and say, I want a new instance, right? I need 4 of this or 5 of those. And that tends to be the result of a developer who's monitoring the application through our monitoring tools or through something like System Center on the IT side. So if we take a look here, I would normally see if this application was live and active, utilization numbers. So let's say that it was being hammered, I might see that I'm at 80% utilization for an average of 24 hours. Number of sessions active. And this information could show up on a streaming graph that would then tell me, oh, well, I do need to take manual action. So in those instances where the predictability is not there, there's no ability to forecast, and there is no clear kind of demarc point with respect to when you should burst, we always reserve manual control for the developer.
Now, is this exposed at all into the IT admin side of things, where they might want to be monitoring as well or scaling it as well?
It is. So if we go back to the original portal, the IT admin gets an application view of the entire platform. So they have a global view. I could have 500 development teams across my enterprise using this, but they'll see every single application. They'll see how many tiers that app is composed of, what version it's at. In any one of these, if they were to actually drill into the application, they could look at specific properties of specific components. So they can say, well, these developers called me and said they're having trouble. They would see utilization information here. So this particular app, for example, 10.76% of a 500 megabyte memory allocation, and they could take manual control. This is the kind of the back office cleanup side of it. If let's say that a IT person wants to do maintenance on this server, they could move this instance to another part of the infrastructure on the fly. and tear down the server and maybe patch Windows underneath
Right.
it. The other option that somebody on the IT side has is they can say, well, maybe I need to listen to a developer's complaints about errors in the application. They seem to think that there are no bugs and it's infrastructure related. We provide global application logs.
Nice.
So whether it's on Azure or on-prem, they would get a consolidated view of fundamental failures in the app, and they can remedy it by noticing that, wow, every application that lands on node 2 seems to fail. So I would like to move everything off of node 2 and deprovision that.
So what logs do you actually aggregate? Is it like anything written to the event log or the IS logs or the failed request tracing?
So in this case, it's a debug level log. So if you're using any logging APIs like the enterprise libraries, or on the Java side, you might be using something like Log4j. We plug into those logging abstractions and scrape out of that. But then second, we generate some of our own events and logs. Apprenda is responsible for monitoring applications. If you deploy a new app on the platform, we pay attention to its uptime, whether it's alive and well. If it happens to fail and a process crashes, we detect that. We'll scrape a bunch of contextual information related to the failure, regardless of whether the developer wanted that or not. And we'll post that to the developers portal so they can see it, but also to the global view so the IT person can see it. And then we'll revive that application someplace else on the either Azure side of the infrastructure or the on-prem side of the infrastructure.
So do people need, I guess you use the portal to provision a resource, so that resource will be bootstrapped with some kind of agent, Apprenda agent?
It is. So we are fundamentally a peer-to-peer fabric that acts like an application container. So when a developer uploads an application package to us, it's a simple zip file that might have my composite app. It'll have my database workload, it'll have my web services, my front end. We decompose that application into its constituent parts, and we'll actually deploy those components to whatever nodes we deem are healthiest and best, and that fit the compliance and regulatory constraints that you've established through policy. Once they land on that server, we then instrument in agents that are watching that application and that are doing things around availability checks, health checks, and in fact, even messaging and routing. So if your app is using SOAP or REST, for example, to communicate to other components on the platform, we instrument ourselves into that call path, and we'll actually, through our peer-to-peer routing fabric, make sure that we can connect the different components properly. So we really get pretty intimate with the app and ensure that, on-prem, again, you have that same experience that you do on public cloud. Okay, I think one last thing on the IT side is that we try to also give ultimate configuration to the IT department. We believe that these sorts of environments only work if IT can establish policies that make them happy and feel secure, but then turn over ultimate freedom to the developer within that context. So the IT person that is running the Apprenda-based instance can come in and configure everything related to security policy, policy around how resources are managed. So for example, they might say, well, developers are allowed to use a small, medium, and large policy for their app. They can say a small is, we'll see this load in a second, a small is 500 megahertz of CPU, 500 megs of RAM on a particular instance. A medium is something different. The developers can choose from these a la carte items and say, my app needs X, Y, or Z. So once IT has established the a la carte items that you can choose from a resource perspective and all that security profiling has been established, really a developer gets full control to do whatever they want. So going back to the developer portal, once my application is deployed, I essentially manage my application's life from here. I don't remote desktop into a machine or SSH into anything anymore. I don't telnet into a box. I instead say, well, you know what, I need to patch my application. I go to my patching screen and I might select a file that provides a full delta of my app. And Apprenda will evaluate the new binaries versus the old and dynamically patch your application running on the platform. If I need to provide some additional configuration information, maybe I want to specify how I want IIS to treat certain aspects of my app. I can log in through the configuration tab and actually influence those parameters. So ultimately, we try to expose all aspects of control for an application through these portals so that we can normalize the behavior, whether you're on public or private cloud, and really turn it into this level of abstraction.
So if you're deploying an application that has, let's say, the web piece of it, and then it has a database, how do you really specify? Like, am I just giving it, like, here's the database script, or here's the actual database files?
Great question.
How does that work?
So you give us the fundamental creation components for any app tier. On the database side, you give us database scripts, compiled stored procedures, and you package them in that zip file in a specific folder. On the web services side, you give us your compiled binaries, your app config files, debug symbols if you want, that sort of thing. And on the front end, something similar, JavaScript files, HTML5, ASP.NET files. When you upload those to Apprenda, we actually treat that as the model. We're a pretty sophisticated technology in that we don't require that you describe how those moving parts interact. We actually assess that on the fly. So when the zip file hits an Apprenda node, we decompose the app, we learn how the different pieces talk to one another, and we know what the dependency model looks like. And then we'll take that database creation script and go to a SQL Server cluster attached to the fabric and create the database. So.
And does patching work the same kind of way when, like, if you're updating an application, I have changed scripts, same sort of situation?
It does, yeah. So you give us, when you give us a patch, you give us the new state of your app, and then we compare that to the old state, and we learn what the binary differences are between the two, and we'll make inferences and make those changes. On the database side, you'll give us schema changes with respect to your DB, and we'll apply the schema changes.
Okay.
Yep.
Okay.
And on the sort of deployment sort of cycle here and patching, is there a concept of like a staging slot or anything like that you can sort of push to stage, swap to prod?
There is. So what we have is an application lifecycle manager in Apprenda, and we have a forced set of logical stages that we put an application through. Now, when you deploy an app or upload an app for the first time and you're giving us just the binaries, we put that in what we call a definition stage. So it's metadata modification configuration. In fact, I would come to this screen during that stage and specify as a developer whether I have PII or not, as we talked about earlier. If I had a blank here, the platform wouldn't let me deploy to the next stage, which is Sandbox.
Okay.
That's a QA stage where people on my team who have access to the account can play with the app. So imagine doing QA, saying, okay, this is working. And then when you push it to prod, we'll actually swap the current prod instance with the new Sandbox instance.
Okay.
So we funnel an application through that process specifically because they don't have access to the underlying infrastructure resources. Our philosophy is that we need to abstract an app and the developers away from the infrastructure as much as possible. The more affinity there is, the more kind of touch points there are between the two of those things, the less fungible these assets are. So being able to do things like dynamically scale become highly improbable.
Right.
Great.
So the last thing that I'd like to point out is that we also then take over a lot of service brokering responsibility. So let's say that I'm an app developer and I'm using something like Hadoop, right? Maybe I'm using Hortonworks or whatever it might be, and I want to connect to an instance. The platform operator who is responsible for running Apprenda inside my enterprise can set up a Hadoop instance or can set up some other big data store and say, well, I want to publish this as an available add-on for the developers.
Okay.
A developer can log in and actually see registered add-ons. In this case, we have a file share, a network share, and they can bind their application to it. So the application, through an API, can say, I would like the file share service, or I would like the Mongo service, or Hadoop service. And we'll provision access for that application to that particular service based on an add-on that was scripted to do that. Provisioning can mean whatever the IT department wants that to mean, right? Provisioning can be for a service that's on premises alongside Apprenda. It could mean that they want to provision access to some Azure service like file storage on Azure, right? That sort of brokering is something that we end up taking over so that we can reconcile that view and make that the on-prem feeling exactly like the public cloud feeling.
So in this case, I'd assume then the IT department writes the script in this case to create a file share. And when the developer wants to use it, it's just a matter of clicking it, and that will bootstrap that VM to have that on start.
Correct, and that's important in the private cloud for one big reason. If you look at a majority of the applications written inside the enterprise today, a lot of them will have dependencies on things like network shares, and that makes it difficult to move to public cloud right now. This gives us an option to reconcile that so that we can take existing applications and run them in a cloud-like way without having to worry about any sort of big application rewrite. Now, as a developer makes changes to their app and they start to decouple from their internal environment, that application's already running on Apprenda, they could, in fact, at a button click, choose to target the Azure cloud. So let's say that deployment policy isn't managing whether an app is living on Azure or on Apprenda. Then they can forcibly say, okay, I'm good, and for cost reasons or for availability reasons, I want to move it out of our East Coast data center and run it on Azure. They can do that at a button click. So the add-on model, to a degree, exposes these critical services that are current dependencies in any application. But then you can slowly start to peel it away and actually rewrite your application to be more public cloud friendly.
Great.
It also, I guess, removes the common tasks that developers would have to script from application to application to application into something clickable, reusable, and it's just sort of done. Clickable,
reusable, and I think the important thing is consistent, right? One of the worst things that can happen in any environment IT-wise, and I think it's the reason why IT is in the state it's in today, is that everything's an exception to the rule, right? So if there isn't a consistent mechanism for taking an application and coupling it to some service like a file share, you end up with mayhem. You end up with 2,000 to 3,000 applications that all do things a different way. And that actually makes it very challenging to then say, as an organization, we want to move to public cloud. So the more we can drive architecture consistency, the more that we can drive service consistency through things like the add-on model, the higher the likelihood that an app lands on the public cloud.
Typical thing that, you know, in large organizations, IT, you know, they basically want a roll-up but breakdown of billing across different teams. Do you guys handle billing at all in this solution?
We do. So if we go back to the resource policy screen that we talked about earlier, the first thing I do as an IT person configuring Apprenda is I decide what size chunks do I want to offer my development teams, right? And this is what this exercise is. So I've got a small, medium, large here. I could define a brand new one. Part of defining a brand new policy is, well, what tiers do I want to offer this for? This is actually something that applies to UIs and web services, and I want it to be a gigahertz of RAM, but it has to be 4 cores, and let's say 2 gigs of CPU, and then I can associate with it a cost definition. That cost definition can be of some arbitrary unit. What most of our customers do is they'll measure things like gigabyte hours. Okay, so if an instance of a WCF service, for example, has been running for 8 hours, I might have a 10-cent fee for this particular policy. Since Apprenda is responsible for availability, we're watching your application on behalf of the developer, and we're recording all this up and downtime information constantly. Okay, we then associate with it what policy was tied to that component, what cost definition was there, and we aggregate all of this information. The IT staff can then consume this through a REST API and tie it to a chargeback or showback system and actually go to the developer and say, this is what you've used for the month. And this can span, again, their private and public cloud. So everything I talk about here is actually Azure consistent for us. So in that context, they can actually map it to say, this is how much public cloud usage you had, this is how much private cloud usage you had, and this is what it means.
Excellent.
So we do a pretty good job of making sure that all the information is there. The place that we stop, and it's just because it's so different in every organization, is what does executing the chargeback or showback mean? That's usually another system's responsibility.
Great.
Excellent.
Great. Yeah, it looks like an awesome product. You've certainly captured well the different roles that you have in these large organizations. So.
Yeah, I'd say it's probably one of the hardest things that that we had to deal with, in fact, when we started building the company and then the product, is that you have to have this stark realization that there are 2 consumers of technology like this, and it's pretty rare in the IT space that you have this problem. If you think of private cloud in general or hybrid cloud in general, it's very much supply and demand. The IT department is supplying a new service, and they're brokering services like Azure into their data center. They want to do it safely, and they want to do it in a way that is consistent with their overall IT approach. The end user is the developer. So when I used to work at Morgan Stanley, I'd sit at my desk and I'd want to use it, and I'd hit a URL, and I don't know about all this stuff going on in the background. I just want to deploy my app. And unless you recognize those 2 personas and really tune for them, you end up with something that's either too much on one side or too much on the other. So one of our big goals was, how can we ensure that we have the right level of views and processes and workflows for each of these parties, so you can have a full-blown system that allows that internal IT department to really be a trusted internal provider, and tie it together with the future strategy of the company, which is more and more public cloud.
Great. Well, it seems like you're definitely making that a lot easier.
Great.
Excellent.
Thanks a lot.
Yeah, well, thanks for watching the show, and thanks for joining us today, Sinclair. So what we'll do is we'll put some links at the bottom of the show to Apprenda, and we'll put a little bit of description there, and maybe some links to some how-tos, documentation, how to get started with your product. Sound good?
Sounds good.
Thanks for watching. Do you have a Twitter account? I'm a little bit rusty here.
I do. Unfortunately, I use the corporate first initial last name, so it's SSCH.
There we go.
ULLER.
Okay, excellent.
All right.
Thanks for watching.